Hello again, everyone. Welcome to 14.4. We're discussing properties of rhombuses, rectangles, and squares. All of this is dealing with parallelograms because we know that rhombuses, rectangles, and squares are all types of parallelograms. So let's start talking about this. A rhombus, let's color code some things. A rhombus has four congruent sides. So I know that all four sides of my rhombus are congruent. So one thing you might be thinking of, isn't a square a rhombus? Well, you're absolutely correct, but a square is more specific than a rhombus. So let's keep going. The next parallelogram we're going to look at is a rectangle, which is where the classification of a rectangle is to have four right angles. And we do not have to have all four sides to be congruent, because once we have four right angles and all four sides congruent, that makes us a square. So we have four congruent sides and four right angles. So it is essentially a rectangle and a rhombus at the same time. This Venn diagram shows exactly what I just said. We have a rhombus and a rectangle, and where they overlap, a shape that covers both classifications is a square. So you need to have worked through problem 1 for this because your graphic is in problem 1. So we're looking at shape EFGH, and we're trying to determine, is this a rhombus, a rectangle, or a square? So go ahead, pause the video and see what you think. Give yourself a reason for why you think that, and then come back and check your answer. So the first thing we notice what's given to me is that EH and EF are congruent to each other. And since I actually know that this shape is a parallelogram due to what we learned in problem 1, then I can also figure out that HG and FG must also be congruent, and therefore that makes my shape a rhombus because opposite sides are all congruent, and therefore it is a rhombus. There are no right angles, so it is not a square. We just leave it as calling it a rhombus. Take a moment to solve 1 and 2. We've got a postage stamp here, and then we've got kind of like a pattern to print over here. So see what you think about what shapes are both of those. Be as specific as possible. So with all of these problems, remember your special rules for parallelograms before you start trying to solve things. We know that in a parallelogram, consecutive angles add up to 180. Since I'm given this right angle right here, that means this consecutive angle would also have to be 90. This consecutive angle would also have to be 90. Opposite angles are congruent, so this would have to be 90. So we see we have four right angles, and we do not have congruent sides because we know nothing about the lengths of the sides. Aside from that, opposite sides must be congruent because it's a parallelogram. So therefore, the most specific thing we can call it is a rectangle. When we look over at number 2, we see we're looking at one of the parts of the pattern in the shape. We see that two consecutive sides are parallel, let's use purple, or not parallel, sorry, they are congruent. And because I know it's a parallelogram, I know that opposite sides are actually congruent. So therefore, I know all four of these sides are congruent. And when I have four sides congruent and no right angles, that means it is a rhombus. Theorem 50 deals with the diagonals of a rhombus. We know that the diagonals of a parallelogram bisect each other, but now if a parallelogram is a rhombus, its diagonals also form a right angle. So because all my sides are congruent, then when I connect the diagonals, I get a nice right triangle in each section here. On top of my diagonals bisecting each other, we now know that if we have a rhombus, that my diagonals also bisect the angle. So that then tells me that angle 1 is equal to angle 2 because we have a diagonal coming in. It cuts through the large angle A, creates these two smaller angles, which are in fact congruent to each other. That will happen at every vertex here where the diagonals come in. So let's put that into practice. Pause the video and try the got it, assuming you've worked through the problem in Pearson that goes with this, and then come back when you're ready to check your answer. So I know based on our theorem about rhombuses that angles 1 and angles 2 will be equal, angles 3 and angle 4 will be equal because the diagonals bisect, but now what I look at, see all the lines that I've added here, is QR is parallel to PS. I know that because it's a parallelogram. A rhombus is a parallelogram. So therefore, I have alternate interior angles. 2 and 3 are alternate interiors as well as 1 and 4. So I know that they're all actually equal to each other, and therefore all of their angles must be the same thing, which ends up being 38 when you do the math, because I could do angle 1 plus angle 3 plus 104 equals 180. and then I could solve from there. I could also, if you didn't see the alternate interior angles method, I could look at angle P, the entire angle 1 and 2, being supplementary with angle 104, which would give me a measure of 76, which then, because I'm bisected, I would need to cut in half, and half of 76 is in fact our 38 degrees right here. Pause the video and try to solve the angle or the measure of each numbered angle in these rhombuses. I don't know if it'd be rhombuses or rhombi. Go ahead, pause the video. All right, let's just start by talking about number 3. So in number 3, we know the angle 58, and we know the diagonals right here are drawn. Now, one thing that we know in a rhombus is the diagonals always create perpendicular angles, so that should immediately tell me what the measure of angle 2 is. Another thing I want to look at is that 3 up here is not an alternate interior with 58. However, 3 would be equal to this angle that is unnumbered right here, and that angle would be an alternate interior angle with 58. So therefore, I know that this would also be 58, and because diagonals bisect each vertex, I know that these would be equal, and therefore angle 3 is 58. Now moving over to angles 1 and 4, I know they have to be congruent, but the information that I use is knowing that my total angle here, if I combine the entire thing, is 116. So this combined angle must be supplementary to 116, so it would be 64 when combined. So each small angle then would be 32 degrees, and that would lead me to finding my angles 1, 2, 3, and 4 all listed out right there. All right, similarly in number 4, angle 2 should be easy to solve. Angle 1 here, I know this diagonal will bisect, so angle 1 will be the same as my 60 degrees. So we know angle 1 is 60, angle 2 is 90, and then when we figure out angle 3 here, we know these will both be the same, and I go ahead and look at a consecutive angle to it. Well, I know the 60 and the other 60, so these would be 120 combined. So this total angle would be the supplement of 120, or a total 60 degrees. And since it totals 60 degrees, each little angle would then have to be 30. So now we start looking at rectangles, and our important rule for rectangles here is that my diagonals will be congruent. So my diagonal connecting lines, AC, is congruent to BD. And make sure you've worked through the next problem on the Pearson module, and then come back when you're ready for the got it. Go ahead, try it on your own if you can, or come back for the explanation or to check your answer. So just looking at A to begin our problem here, we are given the lengths as binomial expressions of both of our diagonals. Now we know that LMNO is a rectangle, so if we remember the rule that we just learned, rectangles have diagonals that are congruent to each other. So I can set up the equation that my one expression for the diagonal is equal to the other. I can subtract 2x from both sides. I can then add 17 to both sides, and then I can divide by 2 to find out that x is 15. But we're not trying to solve for x. We're trying to solve for the lengths of the diagonals. So I can take one of the diagonal expressions. I chose ln, 4x minus 17, but for x, I plug in the value that we just found, which gives me 60 minus 17, which gives me the diagonal length should be 43. Now to check our work, we can check the other expression. So grab the other MO expression for the diagonal. It's 2 times 15 plus 13. 2 times 15 is 30, and that plus 13 is 43. So both diagonals equal 43, so we know our work is correct. If you have yet to do B, please pause the video and do so. In part B, it's asking me what type of triangle is PMN. Well, because I know that P is the point where my diagonals bisect each other, where they meet, I know that PM is the same length as PN. So I can now say that these two legs of the triangle are exactly the same. Because I don't know anything else about MN, all I can say is that that triangle is isosceles. So please go ahead and try 5 and 6 and come back to check your answer. If you're having any struggles, it always helps to draw the figure so I can pay attention to the order of the points. So I figure L, M, N, P here. So this is the order in which they go. So when I look at LN, LN is actually a diagonal, and MP is actually a diagonal. So hopefully that helps a little bit. All right, so in 5 and 6, we first want to find the value of our variable, then we want to plug it in. So I'm going to scroll down my page a little bit. So 5, I set up that my diagonals are equal to each other. I subtract 2x from both sides, I add 8 to both sides, and then I divide by 3, and I find my x value is 3. I then plug it in to my first equation for ln. I find that my diagonal would be a length of 7. I want to check this to make sure that my answer is right, so I plug it into my other diagonal expression. I get 7, and since they're the same, we are good. I do the same thing for number 6, set your diagonals equal to each other, subtract 3x from both sides, add 4 from both sides, and then I'll divide by 5 to find my x is equal to 1. Plug it into my first expression, I find my answer of 4. Plug it into my second expression, also find my answer of 4, so we know that we are good. So go ahead and try 7 and 8 here. You know that each of these is a parallelogram, so then you have to, from there, classify whether we have a rhombus, a rectangle, or a square, and why. So pause the video, try to figure that out. If you really want to go for it, work all the way through problem 10. So number 7, one of the first things I look at is that because it's a parallelogram, I know that opposite angles will be congruent, so I know that both of the angles I have in yellow here are going to be equal to each other, and then I know that consecutive angles right beside each other, have to be supplementary, so I know that also this angle has to be 90, and this angle has to be 90 because they're both consecutive with my given 90-degree angle. The other thing I then see is that my two sides have been given to me as having the same length, and I know in a parallelogram opposite sides are congruent, so my bottom is the same as my top and my left is the same as my right, so therefore we can now conclude that this shape is in fact a square. Now it's also a rhombus and also a rectangle, but square is the most specific name that we have for it, so we go ahead and just call it a square. In number 8, the biggest thing that we pay attention to here is that I have 4 congruent sides of my parallelogram. I have angles that are not 90 degrees because I know this one would also be 130. My other 2 angles would both be 50, so therefore I see that 8 is a rhombus. Go ahead and try number 9 and 10 on your own. Come back just to check your answers or if you're unable to solve it on your own. Alright, in number 9, the first and easiest part to solve should be angle 2 because it is the angle at the intersection of the diagonals, and I know that in a rhombus, when my diagonals intersect, I get 90-degree angles. So number 2 would be 90, as well as its vertical angle down here would be 90 because it's also the intersection of the diagonals. That will help me in solving for 1. Angle 3 we know is going to be equal to the 50 degrees because this diagonal bisects that corner. And then angle 1 we could solve to be 40 degrees based off the triangle angle sum theorem, where it tells me in any triangle I will have 180 total degrees. So since 3 was 50 and my top angle was 90, 1 would have to be 40 degrees. Alright, because we have a rectangle with JKLM, again, I like to draw out my rectangle so I can actually connect the points that I need to make the lines I want to look at. JL and MK are both diagonals, so I set up that they are equal to each other. I will subtract x from both sides, which again leaves me 0 momentarily on that side. I add 12 to both sides, and then I divide by 3 to find out that my x value is 4. That then tells me that MK equals 4, because if I just replace my x with 4, it's 4. When I replace my x with 4 for JL, I have 4 times 4 minus 12, which is 16 minus 12, which is 4 also. So both of my diagonals measure 4. That is all that I have for you for today's class, guys. Make sure that you understand everything about 14.4. Let me know if you have any questions, comments, or concerns. Do your homework, and I will see you in class. Have a wonderful day.